In this lecture, you are going to learn how to calculate the wheel radius starting from the tire symbol. Using the size marking of the tire, we can calculate the free static wheel radius. Free means that there is no load applied to the wheel, and static means that the wheel is stationary. Also, we can calculate the rolling radius of the wheel, taking into account a deformation coefficient lambda. Let's take as an example this tire with the following marking: 255/60R18. 255 represents the tire width in millimeters, 60 represents the aspect ratio in percentage, and the aspect ratio is the ratio between the tire height, h, divided by the tire width, w, times 100. R means that the tire has a radial construction, and 18 is the rim diameter, d in inches. Now imagine that the tire is not touching the ground and is in air. RWS is the radius of the tire and it's static and unloaded. But then if we put the load on the tire will touch the ground and this radius will become lower because the tire will have a deformation. Also, the rolling radius RW is influenced by the speed of the vehicle. The way to calculate the wheel rolling radius is the following. First, you have to know the tire specification. For our example, the Tesla Model 3, the tire symbol is 235/45R18. Second step is to calculate the tire height. We can calculate the tire height using the aspect ratio equation, this one over here. From this equation, we can take h outside, and then we know that h is the aspect ratio times the width divided by 100. This will give the tire height of 105.75 millimeters. Next step is to calculate the wheel diameter. To calculate the wheel diameter, we need to know the diameter of the rim and the tire height. The wheel diameter is the rim diameter in inches times 25.4 plus 2 times the height of the tire, which gives 668.7 millimeters. The free static radius, RWS, is the diameter of the tire divided by 2, which gives 334.35 millimeters. Now, to calculate the wheel radius during vehicle driving, we need to know a coefficient lambda. So this coefficient lambda is a tire deformation coefficient and has values between 0.95 and 0.98. For our application, we are going to consider that lambda is 0.98. Lambda depends on the tire inflation pressure. Therefore, we can say that the tire radius, RW, is the free static radius of the tire, RWS, times lambda, which gives our tire radius during vehicle driving as 0.328 meters.